Our first talk is choosing the best database for your use case. There are over 400 database management systems in the market. How do you navigate that maze? You'll find out in this talk. You'll hear from Rob Gibbon, Mohamed Naziri, and Michel Tabirao from the Canonical team. Rob is a senior product manager at Canonical with over 20 years of experience in the industry. Mohamed has 13 years of experience in the IT industry, and he is passionate about data stores and distributed systems. And Michel Tabirao is a product leader who is passionate about driving digital innovation with open source. Let's get started.
So today, together with my colleagues, we are going to talk to you about choosing the right database. And for the agenda of today, we are going to start by explaining why it is an important decision. We are going then to talk about how to not choose a database. And then we are going to move to the criteria for choosing the right database for your needs and the question that you need to ask. Then we are going to move to the validation methodology, and then we will move to presenting to you some of the data solution we are supporting at Canonical, and then we'll finish by a conclusion section. So let's start. So today, we are lucky to have hundreds of database solutions that are available for us, but it can quickly get very confusing on to what actually to choose and what to use for every use case. And if you are unlucky to make like the wrong decision, and then you need to switch from one data solution to another solution, then this will obviously incur a lot of cost, but as well incur a lot of risk on your, let's say, migration and your data themselves, as it is outlined here by Gartner, where we think that more than 50% of the data migration initiative will exceed their budget and timelines, and sometimes even harm the business. So that's why it's important to make the right decision. And we will start by explaining the basically ONT patterns, the things to not that you should not be doing when trying to choose a database. So the first thing is, that you would like to avoid is relying on public ranking to pick the most trending technology, because you think, if everyone else is using that technology, then it should be like the right choice for me. Looking at trends and let's say, what are the technologies that are being, let's say, more popular than others is helpful to understand, like the dynamics, and to actually ask question why people do prefer those databases. But only relying on that is not a good decision. The other thing that I think we should, avoid when choosing a database is relying on public benchmark to pick the most performant databases. Why is that? Because if you look, hard enough, then you will find most probably contradicting information. Sometimes, if you take random example like Postgres and Mongo, you will find, blogs and articles claiming that one is more performant than the other, and then you will see exactly the opposite. And while that might be true, meaning that for very specific scenario, Postgres cannot outperform MongoDB, or MongoDB can outperform Postgres, but it does not mean actually that it will be the case for your particular use case and for your particular workloads. The other thing that we think, that you need to avoid is really relying on trending and trends and relying on, let's say, database company using those trendy words in order to attract people, like, vector database or blockchain or AI. We are not saying that, those claims might be wrong, but just basing your decision on those trends might not be a good decision. So the question is then, what are the criteria that we need to look for? What are the questions that we need to ask? And in my opinion, we need to think about different factors. So cost factor, human factor, and use case related factor. So obviously, when we are talking about human factor, we need to think about the knowledge that our people and our teams have for that database. And it's not only about knowing how to use it, but as well knowing how to operate it, what are the pros and cons, what it means actually from ramp up perspective, from training perspective. And it's as well very important to get alignment, because if you are moving from one technology to the other and your organization is not aligned with that decision for whatever reason, technological reason or no, then the, let's say, success probability of your project might be actually very low. The other factor that we need to consider is obviously cost. And when when we are talking about cost, it's not only about the license or subscription that you might be, let's say, using, and sometimes you might need to change from one pricing model to the other with its implication from cost perspective. We are as well talking about the hardware cost and the migration cost. And something specific to the license part is that it's not only about cost in reality, it's as well about as well about strategy. Meaning, if you stick with open source license, then it might mean, for example, that you can rely on the community later on if your vendor, changes his policy or changes his way of offering the service. You might rely on the community to get support or rely on other vendors completely. And it's not something that you can do with closed, with non-open source licenses. Let's put it this way. Another thing that, and arguably is the most important, factor is the use case related ones, meaning that depending on your sector, depending on actually what your application, the one using the database, will need to do, this should ultimately guide you in your decision. And the first questions that you need to ask is, what are my access paths? How am I going to access the data that I'm going to store in my database? What are the data types that I would like to store there? Meaning, are you going to store only JSON data? Are you going to store geographical data? Are you going to have kind of, graph data? And so on and so forth. The next type of question that you need to ask in relation to your use case is everything related to your SLA, the service level agreement that you would like to commit to your end users. And most probably you will need like to provide commitment on your uptime, commitment on the average response time for your query, for your application as a whole, and then it will impact obviously the response time that you need to get from your database, and as well the durability of the data, meaning what is the RPO, your recovery point objective, that you need to commit on. But it's not only about that. You need as well to think about the operability of the solution. We have all the metrics, we have all the tools that you need in order to operate that solution. Will that database allow you to scale, in order to meet peak demands, or let's say varying, patterns of workload or not? You need as well to think about security, especially if you are, in need of complying with certain frameworks. Then whether that database have the security feature that allows you to get that certification will be, of course, very important, or should at least be very important in your decision. And at Canonical, we think that we made some of that work, what are the criteria to choose the right database, and we ended up with a simplified version that you can look in this URL by scanning this QR code, where you find a list of question basically, and list of features that you need to ask and you need to look for when choosing a database. And then for some of the most popular open source solution, we try to give some answers to help you out. So this was everything from my side, and now I'm going to hand over to Rob. Rob, please go ahead.
Yeah, so next slide, please, Mohammed. Yeah, thanks. So we'll move on to the validation methodologies section. So I think first and foremost, you need to define key success criteria, critical success criteria for your database adoption journey. So what is it that you want to achieve? And preferably you should define these as quantifiable in a quantifiable manner. So reduce cost by X, over Y time frame. So that's the first thing. First, define what you want to achieve. Secondly, you need to define the performance criteria for your solution. So things like uptime, expected uptime of the system or of the solution, recovery point objective and recovery time objective, as Mohammed already mentioned. Consistency of the solution, disaster recovery capabilities of the solution, and so on and so forth. So moving on. I think there are more. Yeah. So the next thing is that you need to make a short list of the databases that best fit your criteria. So the key performance indicators that you've defined, or critical success factors, and the SLA aspects, and take your short list, and then run your own performance validation on the technologies that you've selected. and do it more than once. So doing it once doesn't prove anything, but doing it multiple runs of performance, availability, and scale testing will eventually give you a consistent and holistic set of results. Then you need to report on that in an objective manner, potentially a little bit subjective too. Sometimes preferences come into play, but ideally as objectively as possible. Typically, you use a weighting system like a scorecard matrix with predefined criteria and how the different systems performed on those. And then lastly, you need to take into account that the database system that you adopt isn't going to operate in isolation. So you need to be sure that it's going to integrate with your incident management systems, ticketing systems, and general workflows that you have in place in your organization. Those are our suggested validation methodologies. I think we'll now move on. So next slide, please. Yeah, so we wanted to introduce some of the technologies that Canonical offers for database management. So we have, first of all, actually, we have a solution that's a streaming event data system. It's Kafka. We also have a big data solution called TransSpark, which is based on Apache Spark. We have MongoDB, which is a large-scale NoSQL document database. OpenSearch, which is a search engine with many varied applications. We have Valkey, which is an in-memory database system, and MySQL and Postgres, two esteemed relational database systems. And those, we have developed solutions around them, enable them to be deployed and operated in a kind of automated manner on Kubernetes, but also directly on cloud infrastructure, such as AWS, Microsoft Azure, Google Cloud, but also on-premise on VMware, OpenStack, and our own microcloud solution. So moving on. Yeah, so Postgres. Postgres is a solution ideally for transactional database management, so like high concurrency, OLTP, online transaction processing type use cases. So things like, e-commerce systems, booking engines, transaction logging systems, and it can also be used for analytics. So for data warehousing, it's often used for business intelligence as well, and it can do that very well. It's well optimized for that too. And it can be deployed in regulated environments like banking, healthcare, public sector. It's well optimized for that. And lastly, it has capabilities for other use cases as well. For example, search, but also, for example, geospatial and time series. Moving on. So essentially, it's because of its extension set, a single platform that can be used for so many different use cases. It becomes a kind of unifying universal tool for many different use cases, from geospatial to analytics to search, business intelligence, data warehousing, and the classical transactional use cases too. So moving on. Yeah, I mentioned that we have Spark. Spark is a solution for building a data lake house, a data warehouse on a data lake. It can be used for many things beyond that, but we've built a kind of data lakehouse solution around it. So it's appropriate for very large data sets where something like Postgres or MongoDB wouldn't be able to support. It's also appropriate for building a repository of data for building AI, for training AI actually. You can also use it for analytics queries at very large scale, for business intelligence and what have you. It's appropriate when you have a few downstream applications and users. It's not well optimized for very highly concurrent usage scenarios. In that case, Postgres would do better, or MongoDB. And it's good when you've got a variety of different data types that you want to store, like text data, machine data, relational data, and binary data like audio or video. When you have a combination of different types of data, that's where it can shine. So blended data. Next slide. Yeah, so the architecture of a cloud-native lakehouse or data lake warehouse is this is our recommendation for a cloud-native solution. So cloud-native means that it runs on Kubernetes primarily. So you have a disaggregated object storage system, which is separate from the processing, which is a different architecture to the previous Hadoop architecture, where everything was combined into one cluster. And on top of that, you have access tooling and a query engine. So if you move to the next slide, we'll show how that maps onto technologies at Canonical. Yeah, so we have on the object storage tier, you can bring your own storage, be that S3 or Azure storage, or you can use Ceph, for example, which is a solution that Canonical offers for large-scale object storage that has an S3 API. Of course, you're not limited to that. You can use other object storage systems with an S3 API, for example, Dell ECS, or some other vendor-specific solution. The processing is taking place on a Kubernetes cluster. So the Kubernetes cluster provides cluster resource management services on behalf of Spark. So Spark is a parallel distributed data processing framework, essentially. However, it can be integrated with a query engine called QB, which acts as a query interpreter and planner, and then executes Spark jobs to do the data processing. Lastly, in the top right, on the access tooling or analytics tooling, we offer Jupyter. Jupyter is the de facto kind of integrated development environment, as it were, for data scientists these days. Move to the next slide, please. Yeah, so some of the benefits of this approach, of a cloud-native approach to building a data lake. First of all, convergence of workloads, so consolidation of workloads and having a consistency of ways of working. So with Kubernetes, you're not constrained to just processing data. You can also run any number of other workloads and applications that you might have in a consistent way. So you can consolidate bin pack different workloads onto one cluster if that's what you want to do. So you can combine your Spark workloads with an Apache Kafka deployment, perhaps, and perhaps some custom applications that you've written yourself, and other other stuff you might have. You have them all running on the one environment, consistent way of working. It's future-proof in the sense that many of the market skills available today are around cloud-native technologies, and therefore versus something like Hadoop, really, you've got a lot longer to run in terms of supportability. The disaggregation element, so separating the storage from the compute, means that you can shut down or spin down resources when they're not being used, so compute resources, and leverage cost-optimized storage systems like S3 or Azure Storage, so that you can really drive down the cost of computing with these large-scale platforms. Next slide, please. Yeah, so some additional benefits here. So performance-related concerns can be addressed with cloud-native data lake. It's not that you can't do this with other technologies too, but in the cloud-native environment, a lot of these things have been very well thought through and very well integrated into the system. So GPUs, InfiniBand and RDMA support remote direct memory access. What these do is they provide, so GPUs give you the ability to run Spark jobs with acceleration, kind of mass coprocessor of the modern age with the GPU. So it will do things like joins, Cartesian joins will be accelerated by the GPU or group by clauses, and so forth. InfiniBand is a networking stack that's different to the classical TCP/IP networking stack. Gives better performance, uses specialized hardware, so it's more optimized for on-premise use than perhaps on a public cloud. Same with remote direct memory access. So from a cost perspective, you can benefit potentially from more predictable and scalable costing, and as the scale grows, you can potentially get more efficiency through the things like the spin down of the compute resources when they're not being used, and disaggregated storage. Last consideration here is that if you want to build this stuff on your own data in your own data center as opposed to using a public cloud. You can do that with this technology too, which gives you minimal lock-in to infrastructure service providers, no concerns about egress fees, and of course, if you've got some state secrets or other sensitive workloads, there's no concerns there either. Yeah, I think the next slides are from Michelle.
Yeah, thank you, Rob. So Rob has covered really good use cases with a database such as Postgres and also the cloud native data lake that features Spark. I have two more to cover, which is OpenSearch and MongoDB. So let's start with OpenSearch. So OpenSearch is a search engine and analytics suite. It's known for its two modules, of course, the search core, which is based in Lucene, and its analytics capabilities that is using what they call open search dashboard, where you can create graphs and different analytics dashboarding capabilities for observability or security analytics. Let's start with the observability as first use case. When you use OpenSearch for an observability use case, you can try to explore it by, from identifying the root cause issues for a distributed system, detecting issues in real time and crucial availability of your web applications, for example, or just understanding the sheer volume of data that you are needing or trying to use when you wanted to create different applications. So the observability use case for OpenSearch is very known. It's also because its OpenSearch capability to correlate lags, to create metrics, to create traces, which is really good for different observability use case. The other use case that I mentioned that uses the OpenSearch dashboard is the SIEM, which is Security Information and Event Management. It's hard to detect sophisticated emerging security threats, especially if you want it to be in real time. And of course, if it requires high volume and complex data. So, OpenSearch actually enables real time data ingestions and analysis, and it has this powerful security and analytics capability that helps identify different patterns and security incidents. And you can, of course, use the OpenSearch dashboard to be able to kind of visualize it. It also can integrate with different alerting tools. And because of that, enterprise can meet compliance requirements and auditing for this reason. Another use case is, of course, the core of OpenSearch, which is a search engine. If enterprises wants to, deal with vast amount of data, and you wanted a search engine that has a minimal downtime and cannot be disrupted, it's necessary that you kind of find a very robust search engine that can help you with making sure that you can process those large amount of data and be able to retrieve information that is needed that won't frustrate you because it's slow. um, OpenSearch itself has fast and relevant search capabilities that allows people that wanted to use the core search engine to be more scalable, customizable, and extensible as well. Lastly, OpenSearch is becoming a technology in the vector search space, and that's why it can cater in the AI and ML. It can be a vector database, um, but at the same time, it has multiple plugins such as ML Commons, Canon plugin, and um, semantic search, which can be used in different types of AI and ML use case. I really believe that it's developing and it's capable to a lot of these use case because OpenSearch is really like a very thriving open source project where a lot of people are contributing to specifically onto its AI and ML capabilities and extensions. So that's it for OpenSearch. And then my next use case will be MongoDB. So MongoDB is a NoSQL database. It's mainly very famous of its scale-out architecture, and as well as capability to be able to store both structured and unstructured data. And this is the reason why it's very good with use cases such as content management. I'm going to highlight one feature, which is the flexible schema of it. It's because it has a schemaless design that allows users to be able to store information such as images, video, metadata, articles, and being able to process that through how MongoDB is modeled as a database. The second use case is IoT. IoT mainly requires highly scalable database. Imagine if you needed to process millions or billions of data points from your sensors, needed to make sure that it'll be able to do real-time processing. So MongoDB supports high throughput, low latency data ingestion, which is very good for IoT systems. The third use case is web and mobile applications. I think would like to highlight the MongoDB's built-in replication for it, so that when you wanted to build your own mobile and web application, you are ensured that everything is okay, and it has an automatic failover mechanism in case there are issues, so that you can minimize the downtime or severe failures that you might encounter. And lastly, MongoDB supports a lot of analytics use case because of its capabilities. It has also multiple plugins to be able to help in different analytics use cases. And I think that's it for an additional two more, let's say, projects. I'm gonna wrap it up with some conclusion with this topic about choosing the right database. Mohammed and Rob has highlighted a lot of really good pointers on how to choose the right database. And let's start with point number one. You really need to know what is your use case. It will really guide you with the selection process on what's the right database to choose. Um, and then the one that Rob has pointed out clearly in his part, where in database server validation means you should really make sure that you agree on a concrete KPI and SLA based on your needs. At the same time, you need to make sure that you consider factors such as cost, license, hardwares, migration efforts, if you need to, of course, move from one database to the other. And Mohammed also highlighted really good point about what to avoid when you choose a database, not just solely on public ranking or benchmark that is inconsistent, but also considering and also not just considering the trends. It's all the pointers that I mentioned above that is also very important. We're not saying that it's not important. You have to look and research, of course, but solely depending on that is not okay. And then, of course, when you choose database, performance, scalability, the storage capability, and reliability is really essential. And this can be accompanied by different technologies, from SQL technologies to NoSQL technologies to big data systems, and ways to design them, like Rob has highlighted with the cloud native architecture. It will be really, really helpful for to solve your needs. And I think that's it. That wraps up all the things we wanted to highlight in this webinar. At Canonical, we can help you with any database needs, so feel free to contact us and we'll be happy to help.